The apparent purpose of science and technology is for the better living and robuster health. And one of the most important sectors in human life is the healthcare, which affects directly our life. That's the background of this project.
Overall, the system will receive command through users' voices to activate the system, use the webcam to scan the patient's face, then using algorithms to analyze health status and publishing them in both dashboard and hardware devices.
At first, we're going to go through the hardware programming.
This is how the Arduino code is organized. First of all, as usual, we need to initialize variables and include all used libraries. And then in setup, we configuring output pin, serial rate, and initializing LCD, Wi-Fi, and MQTT connection. Then we need to run the self-test to testing the operation conditions of our system and devices. Coming to the group, we use switch to go through each phase. For handle ready state, we have a if condition to check if the start signal was sent or not. About handle monitoring state, we have ensure MQTT connected and having an if condition to check Wi-Fi and MQTT connections, and then if condition to check whether stop signal was sent or not. And finally is display info, where we bring the health factors on LCD screens. This is how the Arduino code was programmed. As usual, we need to initialize all variables and include all used library. After that is the setup, where we configure serial rate, output, and initializing Wi-Fi MQTT connection. Next to that, we need to have a self-test to ensure the LED and the LCD is working in a good condition. After that, we use a check serial command to reading income serial command from pattern code, as we're talking about in the computer vision layer, that it receives our voice and sending it to the Arduino system. And this is the ready state, where we're waiting for a start signal, and monitoring, where we're listening for the MQTT results. And also through this, if we're saying stop, if we stop the whole system and go back to the ready state. LCD display, where we display the status and factors in the LCD I2C displays. Fun fact about the LCD I2C, that is using the I2C protocol, which can reduce the number of wires that we need to use, and it can simplify the wiring section. About the MQTT message callback, is a method that we can use to reading the documents about heart rate and status, and then publish it using the MQTT protocol. And over here is about the let's status updating, where the status of our health, which is analysis, will display most visually. Turning left, where the which color is turned on, and action of Wi-Fi and MQTT. And this is the loop, where we use switch to change its state for the whole loop. And yeah, that's all.
Next one, we're going to move to the computer vision layer, which is responsible for voice recognition and image procession through the image from the webcam.
This is the flowchart to demonstrate how the computer vision layer operating in the health monitoring system. At first, it will have a self-checking to ensure the connection and serial port is correct directly, and then it's waiting for the first command start. After we saying start, it will send that to the Arduino to read using the webcam to read the frame and detect phase, and then the algorithm will check if the phase, lighting, and stillness is available, extract signal, and buffer it into the serial or communication. After that, we will check if the buffer is full and interval rich, and then we will estimate the heart rate and checking the quality ratio. Finally, we will publish it to the values and role, which is using MQTT connection, using the structure of publishers, broker, and sender. We will move into the computer vision layer. Because I have a lot of code and programs over there, so we just go through the overall structure. We will not be detailed in each file. So basically, about the source code, that we have the config, where I use it the settings to initialize all our constant that I'm gonna use for the whole program. Face detector and ROI extractor, which is region of interest, is how the camera analyzes the face to sending the signal. MQTT is where we computer vision layer working at the MQTT publishers is sending data through this protocol. RPPG is how the calculation is made from heart rate estimation, lightning assessment, and detecting if we are over movement or not, and also about the extracting and filtering the signal to ensure the data will be collected as good as possible. Serial communication, which is work at the serial listener and sender. At first, it just worked as listener, but now it will work as sender to start and stop in the both way. Utility, which is used for the camera to scan our face, and the voice detector, which is used our laptop microphone to receive the command from our words, and the main, which is operates everything in the one file. And also, I have designed several test files to ensure the code is work as expected before running in the real platform.
The final code tasks is the biomedical analysis platform, where biological calculation and analysis were made.
With the records from the computer vision layer, this platform we use is to analyze it based on several basic biomedical knowledge. And at first, we need to check if the records are valid or not, and if it is, we need to save it into SQLite and the statistic and trend analysis, which will take about 10 readings window. Then we will need to make a risk assessment, like assess our health if it is normal or is safe or it's kind of like potential hazardous. And then we will calculate the health score based on several formulas and updating the records in storage. Finally, we need to publish all of them into the Arduino communication and also the dashboard. Turning to the biomedical analytics platform, we have all of these things. For example, alert management, where we set up the risk level of our health. Analysis, where we calculate the health score, assessing in the risk, and statistic our values of health. Configuration, where we initialize all constants as in computer vision layer. The dashboard, where the resource will be displayed as the website, which will be sent through the email instead of just working on the hardware implementation. The database of the database and the system of the health. The MQTT, which is working at both listener and publishers because it needs to integrate it with the computer vision layer and embedded layer. The report generation to publish as the PDF if someone needs that. The storage is the way to use the database and storage, which is used over there in logs and data processed. The utility, where it's gonna use the logger to handle the power MQTT publishers. And the validation to validate the data is acceptable in the main file, where everything is operated in just one file. As the same with the computer vision layer, several tests in terms of analytics and validator was created to use and test all the code before working in the real project.
Thank you for watching. さよなら。